We're going to be looking at section 2.7 today and understanding the ideas of how we're going to be graphing with regards to two variable inequalities. As we look at starting our graphs, we need to remember our three types of graphs that we could be working with. And those three types of graph obviously are standard form, point slope form, but lastly and most importantly for today, slope intercept form. And so as we begin our problems, we're going to make sure that all of our equations are written in slope-intercept form. Now, just a reminder, slope-intercept form means y equals mx plus b, where m is the slope and b is the y-intercept. So, our second step in our problems is each problem we're going to graph our lines. And we're going to start once again with the y-intercept and then go up the rise over the run. Then we're going to have to decide whether or not our line should be dashed or solid. And dashed and solid is kind of like open circles or closed circles. A dashed line is going to happen when we either have less than or when we have greater than. And a solid line is going to happen when we have less than or equal to or greater than or equal to. Solid line means we go up to the line but we don't include it. Solid line means we go up to the line and include it. Dashed line means we go up to the line but we don't include it. Then we're going to have to decide how we're going to shade our graph. In shading our graph, we're going to use the words above and below. And above is going to happen when y is greater than mx plus b. And our below is going to happen when y is less than mx plus b. So we've got those possibilities there. So let's look at our first example. We've got 2x minus 5y is greater than 10. This form is in standard form. So let's take this equation, 2x minus 5y is greater than 10, and let's solve for y. Start by subtracting 2x, so negative 5y is greater than negative 2x plus 10. Then we're going to divide everything by negative 5. I hope you remember that when you divide by a negative, something very unique happens, and that's going to give us an answer of y is less than 2/5 x minus 2. So, I hope you realized that we're going to be very intentional and that this inequality right there is going to be flipped. And so make yourself a little note that just says, remember when you divide by a negative to flip the inequality. Now, because this is less than, because this is a less than sign, it's going to have two characteristics. It is going to be dotted, and it's also going to shade below the line. So let's graph this. I'm going to go to negative 2. I'm going to go up 2 over 5. I'm going to go down 2 and back 5. I'm going to make myself a dotted line. And I'm going to shade it below. Now, it's always nice to be able to test points when we shade like this to make sure that we flipped the inequality correctly or we didn't. So my test point in this case is we're going to test the point 0, 0. Now 0, 0 is not in the shaded section. So when we test it, we should get a false statement. So I'm going to come up here and put in 0, 0. 2 times 0 minus 5 times 0 is greater than 10. So 0 is greater than 10. That's false. And because 0, 0 is in the non-shaded section, having a false conclusion is correct. That means we shaded the other section. All right, let's look at our next one. And I'm going to change the problem slightly. Instead of making it greater than, I'm going to make it greater than or equal to, just to give us a change from the first problem. So let's graph our line, go down to negative 4, and let's go up 7 and over 1. Because it's equal to, we're going to have a solid line. Remember to put arrows on your line because there's more above the line than below the line. Now, because it's greater than or equal to, we have two characteristics. It's a solid line, and we shade above. With these two characteristics, we have to think what points are above the graph. Well, if I put a dot on the graph and this dot were to fall, would it touch the line? Yes, it would. If I put a dot on the graph and this point fell, would it touch the graph? Well, way down here at the bottom, it would. So the points that are above the graph are the points here in this section. And because it's equal to, we're going to go up to the line and we're going to include the line completely. In this case, it looks like the point 0, 0 is in the shaded section. So we're going to try the point 0, 0. And in this case, 0, 0 should give us a true statement. So is 0 greater than -4? That is true. And because that's true, that means that we did shade in the correct section. So 0, 0 can end up being false or true. It doesn't really matter so long as you know what to anticipate as a possible answer. All right, let's take this and take it now and look at absolute value. So the first step in graphing absolute value is to get the absolute value by itself. So I'm just going to put those absolute value bars there. Maybe you can put the abs value by itself. Second, we're going to graph that absolute value. Now, remember when we're graphing the absolute value, we have a number of factors. We have the number out front, is it a positive or negative? We have then the number out front in front of the absolute value, which has to do with the slope. I'll call it A. Then we have a number on the inside. If it was x minus a number, it would shift to the right. X plus a number, it would shift to the left. And then lastly, we have a number at the back end, and if that k is positive, it goes up. If that k is negative, it goes down. So, once we've done that, then we need to determine, is it dashed or is it solid, just like before. And then finally, we're going to either shade above or below. So you see our steps are very similar to what we've done in the past. So let's take this equation, y plus 3 is less than this absolute value of x minus 2. And let's solve for y. I'm going to make a couple extra notes here. I'm going to say this is a plus. My slope is 1, just to fill in all the possible scenarios. So because it's plus, it's going to be a valley. Slope is going to be 1. It's going to shift to the right 2 and down 3. So that's all our characteristics here. And then lastly, it's going to be, because it is y is less than, it's going to be dotted. And it's going to be shaded below. So let's graph. I'm going to go right 2. I'm going to go down 3. My slope is going to be 1 in each direction. I'm now going to make it dotted. Putting my arrows on, and now I'm going to shade below. As we look at this problem, I hope it's obvious to you as we test a point 0, 0 that that point 0, 0 is not in the shaded section. So when we test 0, 0, 0 plus 3 is less than the absolute value of 0 minus 2. This should lead us a false statement. And it does. 3 is not less than 2. So therefore, the fact that that's false is actually a very good thing. All right, let's look at our final example, example 4 on this page. And we're asked to write an absolute value equation for the inequality. So based on this, let's take a look at some characteristics. First of all, it's a mountain. That means it's negative. The slope is 1. That means the a value is 1. It's gone left 2, and it has no vertical shift, so I'm going to put Vs equals 0. It has a solid line, and it's shaded above. So we're really looking for a lot of characteristics here with which we can write our equation. So here we go. Y, because it's a solid line and it's shaded above, it's going to be greater than or equal to. Because the slope is 1, I'm just going to put a plus 1 there as a reminder that I talked about that. Left 2 means it's going to be x plus 2, and no vertical shift plus 0. Now I'm going to highlight the parts here that you wouldn't necessarily have to put in your final answer, but that's going to be your problem. Now, can you see any issues? Can you see anything where I might have made a mistake? Well, hopefully you realize that it was a mountain, and it should not be a plus 2, but instead it should be a minus 2. So I'm going to put that minus back in there, and hopefully that is a help to you in realizing it. So if you were really writing this or you saw this in the book, you would see something like this. The plus 0 and the 1 just are a reminder of what those slopes are. All right, our last one here, we have a shaded function. Let's look at our characteristics. The slope of our shaded function is, it looks to be up 1 over 4. So the slope is 1/4. The b value is 2. It is dotted and it's shaded above. So y equals mx plus b would be our standard. In this case, it's shaded above and dotted, so that's greater than. Slope is 1/4, so 1/4 x plus 2. And that's going to be our equation. So in each of these situations, we've got to look and consider a lot of different parts. Is it a valley? Is it a mountain? What is the slope? Is it going left or right or vertical shift, solid or dotted, shaded above, shaded below? Let's look back at these and let's do a little test on each of these last two before we conclude. Going back to this point, 0, 0. It falls in the shaded section, so it should lead you a true statement. So is 0 greater than the absolute value of 0 plus 2? Is 0 greater than the opposite of 2? Well, it is. That's true. That means that you have a true statement and we had it shaded correctly and our equation is correct. Let's come over here. The value 0, 0 is not in the shaded section, and so it should lead to a false statement. Is 0 greater than 0 plus 2? 0 is not greater than 2, so the fact that it's a false statement is good. All right, I hope this has been helpful in understanding section 2.7. Your homework is going to be very straightforward. We're going to be working through these problems down here on the bottom. I've snipped them all in for you, so hopefully that's helpful again. But as we're focusing in, here's our homework for tonight.